Hi, this is Professor Pradyot from Leadib Academy. We are discussing basically the interesting IBDP Chemistry SL Paper 1 2019. We are discussing basically the video solutions. But what is more important is that it is not going to be just the solutions, but we'll be discussing the underlying concepts. Okay, so that will make very interesting, and it will be some kind of a revision of the concepts. But in case you are interested in knowing those concepts in detail, you can very well visit our website leadibacademy.com, where we have uploaded the courses for some important subjects like chemistry, physics, math. Okay, so you can very well subscribe to our courses where you will find the understanding in detail. Okay, so let's move on. Look into the question number 21, which is an example of amphiprotic species. So first, let's get our concepts revised. What is meant by amphiprotic? Okay, just to give some idea, it is the species. Let's say it is X. Okay, either it can accept the H plus, okay, it can accept, or it can donate. Okay, both. It is in a position to accept. This is the acceptance of proton H plus, as well as it should be in a position to donate. It is that species. Okay, it means, what is mean by accepting this one? That means it is acting like a Bronsted and Lowry base. Okay, whenever it is accepting. And if it is donating, that means it is acting like a Bronsted and Lowry acid. Simple. So important part that it is acting like both acid and base together. Okay, as per, obviously as per the Bronsted and Lowry definition. Okay, but importantly, it is basically means in terms of accepting the proton and donating the proton. It is not like accept, mean it is not acting like only the acid and base. Then those are called amphoteric, if there is no involvement of basically the proton. But here there is an involvement of the proton. So therefore you need to be careful. This is the amphiprotic. Protic means you can make out that it is a proton, H plus. Okay, right. So now let's try to analyze which species we are talking about, and we can clearly see, okay, this is out of question, this is also out of question, and this is also out of question without thinking. Okay, without any applying any logic. Why? Okay, now we cannot say that because it is not acting, because there is no H involved in all these three, because finally it has to donate, so it should be containing H, hydrogen. So these three are straight way out. Okay, and only our job is very, very simple. Okay, they have made us our job simple, so that means option D. But let's try to, this is the answer, but let's understand how. So let's say HPO4 minus, this is called hydrogen phosphate. So if it accepts H plus, okay, it will give us basically, sorry, I mentioned 2 minus. Okay, it will give us H2PO4 minus. That is, this is dihydrogen phosphate. And this is just the hydrogen phosphate. And obviously in this case, hydrogen phosphate is acting like, because it has accepted proton, it is basically BNL base. Now let's try to analyze that how it is acting like a acid. So what happens? HPO4 2 minus gives away the proton, it gives, okay, it is a donating, and we will get PO4 3 minus and H plus. This is nothing but phosphate ion. So in this case, it is acting like BNL acid. Okay, Bronsted and Lowry acid. Very, very simple concept. Okay, and in this case, the options were very easy because 3 options we could eliminate out of 4 straightforward because H was missing. Okay, if they would have given us 2, then it would have been interesting. But in this case, they have made our job very, very easy. Okay, hope this is quite clear. Okay, question number 22. In which species does sulfur have the same oxidation state as in SO3 2 minus? Okay, so this question is based on computing the oxidation states. So SO3 2 minus. Let's find out what will be the oxidation state. So assume S sulfur as X. Oxygen, we know in the oxides it is -2. So 3 oxygen atom into -2. And overall the charge on this sulfite ion, this is the sulfite. Okay, sulfite ion is equal to -2. So that is X minus 6 is equal to -2, implies X is equal to +4. That means we need to find out the species amongst all those 4 in which sulfur is in +4 state. Okay, that's the question. So let's look into the A, that is S2O3 2 minus. So again, assume sulfur to be X, so 2X, 3 of oxygen, so that is with minus this. Okay, and that is equal to -2. So that implies X is equal to +2. So definitely A is not the answer. Then move on to SF4 2 minus sulfate ion. Assume sulfur X, 4 oxygen, so that will make -8. And this is equal to -2. So X is equal to +6. So sulfur is in the +6 oxidation state. Let's check up on H2S. Okay, H2S, as usual, hydrogen is in the +1. So there are 2 hydrogen atoms. Okay, so that makes +2. Sulfur assumed to be X. Overall, hydrogen sulfide is a neutral molecule. So that will imply X is equal to -2. Again, that is not what is there. Then comes D, SOCl2, sulfonyl chloride. So assume sulfur to be X. Oxygen, okay, is basically as usual in -2. Chlorine is into -1 into 2. Overall, it is 0. So that implies X is equal to +4. So this is what we were looking for. So this is the correct option. The correct option is D. Simple. Okay. So this was based on how to compute the oxidation states. Okay. Question number 23 appears to be interesting. The following occurs when metal X is added to Y sulfate solution and Z sulfate solution. X, Y, and Z represent metal elements. Okay, but not their symbols, and they have given us the reaction. So let's understand what the question is. So let's say this. Okay, so there is a metal X which is getting added to Y sulfate. We do not know, it can be anything, but I'm just mentioning like this, Y sulfate and Z sulfate. Okay. And then they are giving us this reaction. So what is the first reaction? X plus YSO4 giving us X sulfate plus Y, and then X plus ZSO4 giving no reaction. So let's analyze what this reaction indicates. So in this case, X has replaced Y, okay, from its solution. Y means, Y sulfate means like Y can be in anything, okay, SO4 2 minus, okay. So it was in the ionic form. Sulfate means it's a solution, so it was in the ionic form, but after X has been put, X has come into the solution, it had displaced. So what does it imply? That means straightforward, X is more reactive than Y. Whenever, okay, so this conclusion should be very clear and simple, that whenever any element displaces the other element from the solution, that means that element which are displaced is more reactive, okay. So in this case, X has displaced Y from its solution, that means X is more reactive. Simple. Now coming to this, what could be the conclusion? X could not displace zinc sulfate. It simply means X is less than Z or Z, okay. X is less than Z. Simple, okay, because it could not displace. So what does it mean? So overall, it is simple that Y is the least reactive, followed by X, and the most reactive is Z. Simple. Okay, this is going to be the order of reactivity. So the correct option is B. So what concept we have learned? That whenever any element displaces the other element from the solution, that means the one who has displaced is more reactive as compared to which is getting displaced. Okay, simple concept. Okay. Let's look into the question number 24. What is formed at the electrode during electrolysis of molten sodium bromide? Molten sodium bromide. Let's put electrodes. Okay. Plus minus. Obviously negative electrode, because this is the electrolysis. So this is cathode, anode. Let's look into what is going to happen. Okay, the simple logic, there is going to be, when sodium bromide, that is NaBr, when it is going to get in the molten state, so ions will be separated, so there will be Br minus ion, and along with that there would be sodium ion, that is Na plus. Okay, now simple logic, because cathode is a negative electrode, so positive ion, that is the cations, will get attracted. Okay, cations will get attracted, and for the positive electrode, that is anode, Br minus will get attracted. Okay, these are anions and cations. simple. So let's see now what reaction we are talking about. So at cathode, we know very well at cathode always reduction takes place. That means cation Na plus will take one electron and will get converted to sodium. Okay, it will start getting deposited. And at anode, Br minus, as a matter of fact, we will consider two Br minus are losing electrons. Okay, so they will lose two electrons, overall one each. Okay, and these two Br atoms will combine and generate bromine. Okay, so bromine gas will get liberated, Br2. Okay, that's the logic. So the correct option, so on positive, Br2 will get generated, on negative, sodium will get generated. So the correct option is D. Extremely simple. In case of molten salt, it is extremely simple because there is no competing ions. Okay, whenever it is an aqueous ion, or probably there are not the neutral or inert electrodes, then it can be a little bit complicated. But in case of this, it was quite straightforward, very, very simple. Question number 25, which compound is not, okay, importantly, they're asking which compound is not in the same home. So what is mean by a homologous series? Typically, carbon and hydrogen compounds, or for that matter, any organic compounds which are differing with next or adjacent one by CH2. So let's look into this. What is the difference in this? CH2. What about this and this? No, they are not differing, okay, by this. They are just differing by C. What about this? Okay, it is differing by CH4. So it is very clear that this is not in the homologous. Okay, it is not the part of the homologous series. And by the way, it can be easily that A, B, and C, they are alkanes because their formula is CnH2n plus 2. Okay, A, B, C, they are basically alkanes. A is nothing but a pentane, C is heptane, and D is octane. Okay, so it is very clear that, but the B is nothing but alkene. Okay, C6H12. So as a matter of fact, this is hexene. Very, very simple question. Okay, so the correct option is B. Typically, homologous compounds, they differ with the adjacent compounds by CH2. Okay, that is the logic. Or they will have some constant formula. And that has to be followed by each and every member. Very simple concept. Okay, question number 26. What type of reaction occurs when C6H13Br becomes C6H13OH? So let's look into it. C6H13Br becoming C6H13OH. So this is the haloalkane, halogenoalkane getting converted into alcohol. This is the alcohol group. this. So what has happened? Just understand that Br atom has been pushed out, okay, by OH minus group. Okay, OH minus, it is rich in electrons, so we call this as nucleophile. So what has happened? Nucleophile has attacked and it had displaced this Br from here. Okay, so this reaction, we call it as a nucleophilic substitution because it has substituted bromine atom. Okay, it has substituted bromine atom from this halogen alkene and it has formed the alcohol. Okay, so that's why this is called a nucleophilic substitution. So this is correct. So the correct answer is option A. Very simple. Okay, and nucleophilic substitution reactions are very, very important. Okay, these are one of the characteristics of halogenoalkanes. Okay, question number 27, which will react with the halogen by an electrophilic substitution mechanism? It means that out of A, B, C, D, which one is going to be, okay, it will get attacked by the electrophile. So let's understand. Very, very simple. Okay, so consider okay, the benzene. Okay. This is how the correct way of representing. So what happens that there will be electrophile, okay, which can come, okay, it can be anything. Let's consider as CH3, okay, like this. So it can come and it can attack one of this, okay, one of the hydrogen atoms. So electrophile means which is electron deficient. So this is electrophile, okay, or it can be any plus radical. So electrophile will come and attack, okay, on the benzene ring because benzene is having lot of pi electrons or local delocalized electrons. So we can get such compound. Okay, this is basically electrophilic substitution. That means one of the hydrogen atoms is getting substituted by the electrophile. It is not the nucleophile because nucleophilic substitution is not possible simply because there are a lot of pi electrons. Already benzene is having a lot of delocalized electrons. So nucleophile would not prefer, but definitely electrophile because it is looking for a good supply of electrons and that is plentifully available with the benzene. Okay, there are a lot of delocalized electrons. These are delocalized electrons. Pi electron, delocalized pi electrons. And that is what exactly this electrophile wants. It is short, okay, it is a deficient in electrons. Okay, very, very simple. So the correct answer is A. Okay, because we need to check whether anything can act like an electrophile. Okay, so none of them because there is no pi electron easily, but you can check on D, it won't be possible. Okay, it won't be possible to have this. Okay, electrophilic substitution, it is not possible on this. Okay, by the way, this is cyclohexene. Simple. Okay, question number 28, which compound cannot, okay, very, very important, undergo addition polymerization? So let's look into this. Option A, what is happening? H3C, okay, H3C, double bond, CH3, CH3. So what will happen that this one of them, okay, the pi bond can open, okay, and it will get converted into like this, H3C, okay, H3C, C, H3 and CH3, and let me show importantly the continuation bond. So these can be possible, okay, with A. Let's look into the B. What is the scenario? B is looks to be straightforward. H2C double bond CH2, okay, opening up. So we will get H2C CH2 and again opening up of the continuation bonds. Okay, so it's very, very simple. Even let's look into the D. Okay, let me remove this. Okay, so even in case of D, double bond CH double bond CH2, and then it can get like this, CH CH2, and show me this. Okay, this is possible because double bond breakage. But in case of C, there is no possibility because we cannot disturb this. Please remember, we cannot disturb the aromaticity of, okay, aromaticity of the benzene. It is the most stable configuration. And here there is no double bond. So there is no possibility that we can open and form the continuation bond. So in this case, it is not possible. So what is important is that double bond should be in a position to open up to form the continuity bond. Okay, and that is not possible. So simple reason that the correct option is C. Okay. Question number 29. Okay, what is the value of temperature change? So final temperature, sorry. Okay. So final temperature is, okay, so let me put it, T final is equal to 15 plus or minus 1 degree Celsius, and T initial is equal to 15.0 and 2.0 0.1 degree Celsius. So they are asking what will be the temperature change. That means T final minus T initial. So what we will do, we will subtract this and this. 15 minus 2, and very important that this is, please understand that this is the uncertainty in the reading. Okay, this is uncertainty in the T initial 0.1, and in the final it is 1 degree Celsius. So always remember that the uncertainty gets added. So it would be 1 plus 0.1. Okay, please remember this, that uncertainties get added when you either take a difference. Uncertainties get added. Okay, they are not subtracted because that is like an error. So error, irrespective whatever you do, okay, errors get added. Okay, so it's important to understand this logic. So therefore, it would be 13 plus or minus 1.1 degrees Celsius. Okay, 13.0 plus or minus 1.1. So what is the important this one? That whenever we take a difference, the uncertainties get added. Okay, if you would have been adding, then straightforward. But even if we are subtracting it, two parameters like final and initial, still the uncertainties get added. Okay, errors never get reduced. Okay, that is the learning what we have. Question number 30. Which technique is used to detect the isotopes of an element? Okay, so the answer is straightforward if we are aware of the principles. So the answer is straightforward, mass spectrometry. The reason being that it separates out the particle based on mass upon charge ratio. Okay, this is the principle of separation. Okay, it's a straightforward method. So in case of isotopes, we know isotopes means simple. What are isotopes? Isotope means different atomic mass but same charge or same nuclear charge. So in that case, the only best bet is to use the mass spectrometry. Okay, so you need to have understanding of the principles of these separation techniques. Okay, and based on that you can easily make out, okay, that the only correct option is option A. Simple. Hope you have enjoyed this video solutions, okay, of the paper 1 of Chemistry SL, November 2019. In case you are interested in understanding in detail, okay, then please do visit our website, okay, leadibacademy.com, on which we have uploaded the courses, because these courses will be covering all these kind of topics of the important subjects in detail, okay, so that there will be a clearer understanding. Okay, okay. Thank you.